Hi guys, up until this point we have learned on how to draw your complex number in Argon diagram, and let's see what else that we can do in Argon diagram. So in this part we're going to learn about modulus and argument. This is the things that we can do when we have Argon diagram. So modulus means that we are going to find the length, this line, the length of this line. And what is this line stand for again? This line indicate the length of our complex number from its origin. In other words, how far it is from the origin. So the way to calculate for this is by using R, and R here, right, the formula of R is square root of a squared plus b squared. Let's try to demonstrate it through example 1.9 and exercise 1.6. So in example 1.9, okay, we have the first question, which is 12 minus 5j. The way to find its R is by using the formula of R, square root squared plus b, which is negative 5 squared. Okay, which will give us 13. As for the second one, right, we have 1 plus 10j. Okay, so the formula of R again, 1 squared plus 10 squared. And if you calculate this, what you get is actually not a whole number, it is in decimals. So to be a little bit safer, whenever you encounter with a number that is not a whole number, right, the way to try to bring everything is by giving the answer that is in a form of whole number. So for this case, the answer we can let it remain before cert. So the square root of 101. Now let's look at exercise 1.6. So in exercise 1.6 we have number 1, negative 3 minus 4j. Okay, squared, negative 4 squared. Right, actually the negative is not really matter, because as you may know, when you square it, it will actually gone, right? But I just want us to practice a good habit of writing down the exact question, so that maybe later you won't forget. Right, so the answer for this one is 5. Okay, as for the second one, you have 5j. Let's again write down in full the complex number form, which is 5j is its b, its a is actually 0. So 0 plus 5j. Okay, if you put it in the form of square root, R I mean, 0 squared plus 5 squared, you'll get also 5 as its answer. Okay, again remember that all of this calculation is actually reflected to the length of line, this line. In other words, the location of your complex number from the origin or 0. Okay, now let's look at the next part. Okay, the properties of modulus. Let's look at it a bit. What happens if you do this before and after? So in terms of conjugate, if you find a modulus before conducting a conjugate or after conducting a conjugate, it don't really matter because it will be the same. Right? By logic, because when you conjugate, symbol is changed, but it doesn't matter it is changed or not. When you square it, the negative will become positive, so it will be the same. As for this one, z times z conjugate is equal to the modulus of z being squared. And for this one, z1 times z2, the modulus of z1 times z2 is the same as the z1. Find the modulus of z1, find the modulus of z2, and multiply. They will give you the same number of modulus. Now for this one, the same as multiplication. Either you divide it and then find the modulus, or you find the modulus and divide it, you will get the same answer. And the same goes for power. You power it, find the modulus, or you find the modulus and power it, it will give you the same answer. But for this one, right, summation, if you sum and find the modulus, or if you find the modulus and sum, you can get either the same answer, or it might be, this one might be lesser. Okay, that is the properties of modulus. In the next part, we're going to talk about argument. Thank you.